I'm going to lose my exemptions, that's right. Okay, let's look at our semester review answers. Okay, you guys asked me about number 1. The prom committee is formed of 15 seniors, 8 are male, 10 are juniors, 5 of those are male. So I think the way that I figured out for it to be a male or a senior, yeah, well, I knew it's all of these people, right? It's all of those people, right? Because it's 15, okay? But then I don't want some of these juniors, but how many of these juniors do I want? I want the 5 that are males. So that's how I knew it was a 20 right there. And then it just reduced to the 0.8. Okay?
Okay.
Yes.
When I did going back to my notes, it said probability of A or B, probability of A plus B.
Sure. You could do, right, you could do that formula, which is the probability of males plus the probability of seniors minus the probability of male seniors. And so, yeah, if you want to go, if you're a formula person and you want to go with formulas, that's the way you would do that. You would say males are, there's 13 males and 15 seniors, and then I want to subtract away the male seniors. Okay, so that's going to come out the same way. All right, next. Number 2, questions there. Okay. What about my question? Oh, okay, how are you doing on discrete and continuous? Yes, remember discrete is count. The light bulb was just too long, too big, too difficult. You can have time in minute increments. Okay, so that to me, the lifetime of the light bulb, that's just too much stuff. You're going to have too many amounts. So that's why that would be probably continuous and probably be a normal model, I would expect. Okay. 4, don't, I want you to make sure that you are reading your vocabulary cards for this review. Please go over, remember what blocking is, and all of those things back there from the beginning of the year with blocking and all the different ways that we did things with lurking variables and placebos and your control group and all that. Okay, you remember the difference between a study and an experiment? Good. A study is something that's just there and you look at it and you analyze it. You know, you studied the behavior of these past Swedish men that were taking a particular drug, and then you took data from that. Whereas an experiment, you actually assign a treatment to it. So you take so many people randomly, you give half of them this medicine, and you give half the placebo or whatever. Okay. Question on 4. 5.
I had a question. My question for 5 is I don't remember how to get it on my calculator to get R squared.
Okay, very good. How to get R squared? If you can get R, you just square it to get R squared.
Well, no, I mean, there's a way that you got the list on the
yes.
computer.
Okay.
I forgot.
Well, okay. So what you need to do is put this list into your calculator. Let's just go ahead and do that real fast.
Like you said, it's what the mode.
Yes, you do have to turn your diagnostics on.
That's.
Okay. Okay, so let's make sure we have our diagnostics on. And so this, you cannot get your R if your diagnostics are not on. And so we're going to go second catalog, and I'm going to go down to D's. And then I'm going to turn my diagnostics on. So enter. So the diagnostics have been turned on, and so now it'll give me R. Okay, and so then I go to my list. I'm going to enter in my information here. There's my X list. And then my Y list that corresponds. Oh, I messed up. 3, 4, 5, 6. Okay. Now, then I go to calculate my linear regression, stat, over to count. Number 4, enter. And now it gives me R and R squared. Okay, so those diagnostics need to be trained. All right. Then you can answer those questions 5, 6, and 7. Questions on that. All right. 8. What about categorical? Okay. Are you pretty okay with categorical versus quantitative? Okay. All right. 9. How about that? Because I thought that one was kind of strange. The median is the measure commonly used for income distributions because. Okay. When would we want to use a median? Think back to the beginning of the year when we talked median as a better choice of measure because it's skewed. So that's how I came up with that. We would use median when it's skewed because the mean would be what if you have a skewed distribution? It'd be pulled, yes. It'd be pulled. If you had a skewed right scenario, that mean would be pulled up because you have some outliers up there. If you had a skewed left, then that mean would be pulled down below the median because you have some skews, okay? Number 10. Okay, are you all right with the median being in between the mode and the mean? All right. 11. Okay. Which of the following measures will be most useful in deciding if a group of individuals varies more with respect to height or varies? Okay. Standard deviation because that gives you information about variation. Okay. All right. Now, box or stem and leaf plot. Yeah, I kind of struggled with this one. I didn't like the answer that was given on number 13. I was like, oh, I wanted to say, well, from 0 to 17. I don't know. So, I guess that's actually, did that say 10 to 17? Yeah, see, I wanted to say, mostly concentrated here, but that's not what happened. So, I didn't put anything like that on the test if I wasn't sure about it, so there you go.
That's very good. Because that's the one of it has to be 0, 1.
Yes, very good. How did you know it ended in a tie? Because it's the difference in their score, and if the difference in the score was 0, then they had a tie. They had the same score. Okay, good. All right, and then number 4, we already talked about that. Skewed distribution, the mean is greater than the median because the high scores get pulled up. Okay. All right. Now, please, you need to read your vocabulary cards and look for your vocabulary in the chapters if you don't have vocabulary cards. On all those things like census, control, experimental, all your sampling things, voluntary response bias, convenience sampling, stratified random samples, systematic sampling. I'm just rambling off all these vocabulary words that you've really got to just look back at to refresh your memory on. Okay? All right. Questions on 16? Well, because you don't know if L and M are independent or if there is an overlap. You don't know if that's 0.5 and that's 0.2, or if there's something here where there's, 0.1 in there or something and it's changing. And maybe this is 0.1 inside here and then that makes it that. And you don't know that, so. Yes, if correct, if they were independent, then yes, your answer would be 0.7. But you don't know if they're independent, and so therefore you can't make that determination. Okay? All right. 17. Is it okay? I'm just kind of going straight through these and answering your questions. Make sure I don't, then ask me when I get there. Okay, I kind of said this. Remember, The difference between a study and an experiment. An experiment, you have a treatment that you are assigning a treatment to a control group. Whereas with a study, you're just looking back and studying. So on this problem, okay, so on this, we assigned one group to do what? That's the treatment, exercising an hour. And so then the other ones are instructed to do no exercise, so that's the placebo group. Or control group. I couldn't have a placebo with that. All right, and see, look here, number 18. Remember all these different types of sampling here? Questions? Systematic is, you know, every 50th person you started at a random place. Remember the difference between stratified and clustered? I have to look at definitions on that, but clusters like I with all of the first grade classes in the whole district, and I randomly select one first grade class. That's my cluster. Or I randomly select 3 clusters of first grade classes. Okay, and then I sample every single one in those first grade classes. Stratified would be, you know, 9th, 10th, 11th, and 12th, and I want to make sure that I get 3 from 9th grade, 3 from 10th grade, 3 from 11th grade, and 3 from 12th. So I'm going to get all 3 samples. That'd be stratified. Okay.
Classes.
3 people. But I could do multi-stage, and I could get 3 9th grade homerooms, and 3 10th grade homerooms, and 3, and so on. Okay? Avery, what was that? Okay. All right, 19. It did say it was normal, and so were you okay with this? Did you get stuck in thinking you had to get a different standard deviation or anything, or were you fine that we were just talking about chapter 6 here and a regular parent population? So there we go. By the way, I know I had a question. Abby had asked me, do they use parent population? You know what? They don't use the words parent population. They just say the population. Well, that means everything. I think I'm kind of just being redundant, you know, and re-stressing that it's the main population when I say parent population. Okay. Now, this is on your formula chart. How to calculate this, something given something else, that is on your formula chart. And that is this right here. Okay? So you'll find it on your formula chart. Did I reverse it or something? Oh, it should be over D, right?
Wait, is me giving it?
Oh, okay. Oh, this I should write as this. Yeah. Whatever given C, that's what's always on the bottom. Whatever you're given, because that's what it's out of. So that's always on the bottom. Okay, sorry about that. All right. Okay. And so since I knew probability of C, I didn't know the probability of that. Okay, but I did know that, so I knew that, so then I solved. Okay. All right, what about correlation stuff? R, remember to turn your diagnostics on. What is this? A negative. So here's my thought process. I thought a negative slope. Okay, so how could I describe that? And so a picture helped me. Because if my x's are low, then my y's are high. And so that's how I got D. All right, number 22 came from chapter 16, expected value. Okay, you guys remember expected value? And then do you also remember the Pythagorean theorem of these things? Expected value, I'm going to have to do what? You know, 1 times 0.35 and 2 times 0.20 and all that kind of stuff. Now, if I had 2 different standard deviations of random variables, could I just add standard deviations together of random variables? No. What do you have to do? Only variances add. So remember that, and I think we actually get to that on the free response problems. Okay. I didn't like this question. I don't know. Did somebody find the right answer? Because I actually didn't.
I did.
Did you really? Well, I just called it. See, because here's the way I did this. I said, okay, you know what residual is? So you have to find the residual is actual minus predicted. So this is actual. And then, of course, your prediction line is predicted values. So what I did was said, okay, so what's predicted? What's the predicted y at x equals 4? So the predicted y at x equals 4, so I plugged it into the equation and I got predicted was 4.21. But what does it say actually happened? 7. So what's that difference between what they predicted happened and that? That's the residual. So I got a residual of 2.79, which I think is actually closer to 2.5. So, no, I don't. Wait. Oh, it is closer to 3. Oh, yay. I just can't add and subtract. Excellent. Okay. So it is closer to 3. Yay. Yeah, so they said 2.79 is closer to 3 than 2.5. So that is right. Yay. Closer to 3 than 2.5. All right. And it's only less than 40. Yay. Okay. 24. Okay, you remember influential points? That definition of stuff about influential points. Okay. Remember both of the clown? Here is comedians and their shoe size. No relationships whatsoever. But what happens when I put both of the clown's shoe size in there? And his IQ, he's really, really smart. So look right there. Then what did that do? That completely then made it have a relationship. So by leaving both of the clown out, it significantly changed this line. It, you know, from having a relationship to not even having one at all. So that's what a influential point does. That's just the definition. Okay? All right, 25. Okay, question there. Okay, I got it right here. Okay, so the question is this. What's the probability that a student has seen both given that they've seen at least one of the movies? So here's my work over here. Okay, so let's see here. Probability that you have seen both given that you saw at least one of them. So out of all of those people who saw at least one of them, which is 90 people, these 90 people, they saw everything except for nothing. So that's these people have seen at least one, right? So out of those people who have seen at least one, how many have seen both? How many have seen both? 50 of them. So that's how I got 5 out of 9. Okay? All right, and then 26. You have to have this definition memorized. That is definition of independence. The way I remember it is really, what is this saying? B has no effect. Trying to think of your take it. Wait. That's all right. So B has no effect. Given that B happens, it has no effect on A. Okay, so that's how you do that problem. That's why that works. Okay, almost done with the 27 omits. 28. Correct. Oh, I'm going to put one like 27 on the test, even though you can't read it or anything.
Yeah.
Which of the following makes it easy to compare center and spread? Box plots. Remember, side-by-side box plots makes it real easy to compare all those different things. Okay? 29. Okay, so number 29. I want to do the probability that there are no more than two, it takes her no more than 2 tries to be successful. Okay, so that means that she can be successful on her first try, or she can be successful on the second try. So the probability of getting it the first time, okay, so that's immediate, plus not getting it the first time, but getting it the second time. Okay, so that's how you split that out. And then you just add those 2 separate ones together. Okay. So now on number 30, this is somebody else's review. I actually like B the best, but he says C's the answer, so I don't know. But I did not put that on the test, since obviously there's a little confusion there. Okay, next one, number 31 and 32. Okay, so this is another given problem to practice. The probability that they had no violations in the last 12 months, given that he is 18 or older. Okay. So look at your given formula. None in the last 12 months, given he's 18 plus. Okay, so straight from the formula chart, I wrote that out there. And so none and 18 plus is right here. So that's how I got 0.45. And then all the 18 plus people, that would be this whole thing right here. So that's why it's out of 0.6. Okay, so then that calculates to be answer choice A. And then 32 is saying the probability of being under 18 or having one violation. So probability of being, under 18 plus the probability of one violation, but you have to take away the double counted. Okay, and that's actually just like number 1 that we have done. So let's see, 18, the probability under 18 is 0.4 plus probability of one violation. Let's see here, one violation is this column here, so that's 0.26. But then I need to take away these that were double counted, and that was 0.12. All right. Okay, number 33, you do need to make sure that you have got how to solve this log problem, okay, and how to solve logs. And I actually noticed that over here on my work I had a mistake. Okay, but what you want to do is this particular teacher uses linear regression number 8 instead of number 4 in your calculator, and that's A plus BX. And so that's why he writes his linear regression as 4.32 plus 1.1192x. Okay? So, alright, so if I want to solve for y, then how do I get out of a log? How do I get out of a log? Well, from algebra 2, you know that you raise things to base 10. So I have 10 log y and then 10 to the 4.32, multiply, not add, because remember when your exponents are adding, your bases are multiplying. That's exponent rule. 10 to the, and then this should have been, this is where I messed up on my answer key, that should be a log x right there. Okay, so what happens is this. These 10 and logs cancel, so that leaves you with just y hat. And then this is 10 to the 4.32 times, and then these logs cancel. So what that does is bring the x down, and so then it's x to the 1.1192. Logs cancel and this x comes down. That is why it computes out to be that. So you need to rewrite that and think about that if you have issues with solving logs and miss that skill from Algebra 2, okay? Because there will definitely be one there for that. Okay. 34. Z-score of -2. I mean, that's pretty basic. Your grade is 2 standard deviations below your mean on this exam. We've been talking about that all year long. 35. Okay. 35, I ran my actual trial. So here's how I did that. Okay, so they give you a set of random numbers. So let me just go ahead and run this. I'm going to say a trial is selecting a toy. Right here, I state what a trial is. A trial is selecting a toy until I get all 5 toys. So I want to get all 5 toys. And then they assigned this already. A trinket number 1 is represented by the values 1 and 2. Toy number 2 is represented by these values 3 and 4. And then toy number 3 is represented by 5 and 6. Toy number 4 is represented by 7 and 8. Toy number 5 is represented by 9 and 0. So, here's how I run the trial. I look here at my numbers and I go, okay, I'll keep that toy. That one's a repeat. I already have that toy. That's a repeat. I already have that toy. This is a new one. Okay, and then 9. Okay, that's a repeat. I already have that toy. 5. That's a repeat. I already have toy 6. From this number 6 here. 0 is a repeat because of 9. 3 is a new toy. 4 is a repeat because of 3. 0 is a repeat. 5 is a repeat. 7 is new. So this is how long it took me to accomplish trial number 1 and how many Happy Meals or whatever it is did I have to do. I had to get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. It took 13 Happy Meals or 13 plates to go through until I got all 5 toys. Okay, so that's trial number 1. And so then I kept going until I did what I asked. Let's see. Oh, it said to run 5 trials, so I did that. So I did that process 5 times, and one time it took 13 plates, and one time it took 14 plates, and one time it took 9 plates, and the next time it took 9 plates, and the last time it took 12 plates. So I averaged all of those together, and I got 11.4. So, on average, rounded to the nearest whole number, you'd have to buy 11 Happy Meals, or 11 plates, to get all the 5 different toys he wants. Okay? Alright, number 36. If this is your standard deviation of the sampling distribution, well, remember that by definition and formula, that right there is your population standard deviation by the square root of n. Okay, well, here's that. And the square root of n is 10. If the square root of a number is 10, what is that number? 100. Okay, so that's how you get that. And then the last one, number 37. Okay, very important. Please do not forget that the Pythagorean theorem of statistics, which standard deviations don't add, only their variances do. So, mean. Sure, I can go 71 minus 66 and get 5. Okay, no problem there. Standard deviation, remember the cereal box? Just because you're pouring out cereal doesn't mean you have less variability. In fact, if I have a box of cereal and I pour out some cereal and I'm not sure what I started with and I'm not sure what I put in the cereal box, I have more variability. So this is one standard deviation squared. This is the other standard deviation squared. And then I take the square root of it to get the standard deviation. That's how I get 5. Just like Pythagorean theorem. Okay. Now, on the free response, the first one, I think, when you describe your data set, you have to do all of these different components here. Okay, so to discuss it, you'll use center, unusual features, shape, and spread. And so what I did was I pasted the stem and leaf plot right here. And there it is. And so I actually kind of did the easy cheaty way, and I went into my calculator and put all that data in there, and I'm not even going to do it for you. I promise you. But I put all of the data into my list 1, okay? And then I did calculate my one variable statistics. If you do that, and you scroll down, it will give you the 5-number summary. Okay, it'll give you all you need to know. Okay, but I want to remind you what IQR is and everything. Okay, so let's take a look at a box plot of this and then talk through it. Okay, here's a picture of it. Okay, so on your box plot, remember you have your minimum. This is the lower 25%. Q1 is a value that is above the bottom 25%. Then you have your median. Your median is above the lower, it's right in the middle, so it's above 50%. Then you have Q3, and that's above 75% of things. And then you have this top 25%, top quartile. Now the IQR is this middle. That's the inner quartile range from Q1 to Q3, and that encompasses 50% of your data. You know, if you're kind of thinking normal model-ish, but this just is 50% of your data in there. So, to calculate that IQR, right here, you do Q3 minus Q1. And in this case, that's how I got 11.5. Okay, so now outliers. This is the thing that I think is a simple rule, but a lot of people would mess it up on the test, and I would get upset at that, so let's remember our rule. To get your upper fence, it's 1.5 IQRs above Q3. So I went 1.5 IQRs, and here's my outlier fence at 37.75. So therefore, it's 42, actually 40 and 42, because I can see it from the plot. Okay, now let's see if there's a lower one. That's the quartile 1, not median, it's outside of the Q1. Minus 1.5 IQRs, that brings us to this outlier fence, and that's at a negative. Well, the minimum's at 3, so therefore there are no lower outliers. Okay. So real quick, let's go back up here. Here's how I knew 40 and 42 were my two upper outliers. And then nothing below 3. So, and don't forget what the quartiles mean. We already discussed that. So there's the anatomy of our box plots. Okay, number 2. You have to be able to read your computer printouts and understand what that means. Okay, so here, these coefficients are where you are going to get the information for your linear equation. This would be the constant one. That's going to be your y-intercept. Okay, this is going to be your slope because it is with time, and that's going to be your variable. Alright, so I have that here. X is my time, and it describes it for us in half-hour intervals, increments, half-hour increments, okay? Y hat is going to be the predicted volume of components that they make of these PCs. Okay, so then it goes through these different things it wants you to answer, and so let's go through those. A, it wants the slope and interpret it. So there it is. There's the slope, and that means that for every half-hour interval, the production volume will increase by 64.768 components on average. Don't forget your wiggle rooms. Okay, coefficient of determination is your R squared. Remember to look over your vocabulary. And that's 93.2%. Remember our canned statement? 93.2% of the variation in Y, well, that's the production volume, is accounted for by the variation in the amount of time spent producing components. Okay? In English, what that is saying is 93.2% of the reason that the volume changes is due to the different amounts of time that you spend producing those components. Now the other portion is due to other things like the quality of the machinery, if it's a Monday or a Friday or whatever. Okay. C, correlation coefficient R, indicates the strength of the relationship and how well a linear model represents it. And don't forget you have to turn your diagnostics on to get that. So, there's a strong positive linear relationship between the production because that correlation coefficient was pretty close to 1. If it's pretty close to -1, it'd be a strong negative correlation. Okay, 2D, the regression equation was this. Now, you have to do this or fill in your words. The volume, predicted volume, and here's your slope, and then here's your variable, time, in half-hour increments, plus this. Now, frequently y-intercepts don't make sense. Does it make sense that at 0 time you're already starting with a volume of things? No. Alright. 2.5 hours is 5 1/2-hour increments. So I just plugged 5 in right there, and that's how I got my answer. Okay. And then number 3 for response. Okay, this one is about random variables. So lots of things that we may and may not have forgotten about random variables. Okay. So the probability that the airline can accommodate everyone who shows up. That means, see, it has 100 seats. So that's all these people here. If it can accommodate everybody who shows up, the probability of that is these probabilities added up. Okay? B, for the next 10 flights, what's the probability that 8 or more can accommodate everyone? Okay. So, if this is the probability of accommodating people, right here, then there's a couple ways you can solve 3B. If I want 8 or more, that means I want the probability of 8 plus the probability of 9 plus the probability of 10. So, that's pretty easy. You can do binomial PDF for 8 people, plus binomial PDF for 9 people, plus binomial 10 for 10, or for 10 flights, not flights. Okay? You also could go the flip side to that, which would be 1 minus everything up to 8, and that would be 1 minus binomial CDF, because that's cumulative of 7. Okay? So there's the two different ways you can do that, and they come out with the same. The reason this is a 7 here is because it's up to and including 7. If I had put an 8 right here, then 8 would have been included, and I don't want 8 in that. I need 8 to be over here in the ones that I'm counting. So those are two reverse ways of thinking about it. Alright. Next one, not all passengers can be accommodated. Well, that's all the rest of those probabilities. The opposite of 3A. And then 3D, what's the probability that not the first 4 flights are okay and you wouldn't be able to accommodate it until the 5th flight? Right there. So I laid them all out there. The first one's good, the second one's good, the third one's good, the fourth one's good, the fifth one can't accommodate everybody, and so that's that probability. I don't know the answer to 3E. I mean, I know the answer is 0.06, but why? I don't know. I need a good explanation for that, so come and tell me. And then 3F is this. It's a formula, okay? It wants, so it's the expected value, so you have to add all these up. It's on your formula chart right here. It looks like this on your formula chart, summing up all x's times their probability. Okay, so that's this. 95 times 0.05 plus 96 times 0.10 plus all the way up to the other one. I'll show you where I'm getting those numbers from. Those are coming from the table. 95 times 0.05 plus 96 times 0.10 plus 97 times 0.12 plus all the way through the end, 105 times 0.01. That will give you the average, otherwise known as the expected value. Okay, now, the standard deviation is much harder because you have to go through the variance. This is on the formula chart. Look on it, and that's the only, you don't get a standard deviation formula, you just go through the variance. So it's a summing of, here it is. So this would be your x values, so like 95, okay, minus that mean that we just calculated, okay, square that quantity and multiply it times the probability of that data value. All right. You have to do that all the way through. And once you do that, that's still just the variance. So this is still, this 4.4 is still just the variance. You have to square root it to get the standard deviation. Okay. And then the last one, 3G, to do the mean can be multiplied by 10. That's no problem. But you cannot do that with the standard deviations. Remember, standard deviations, you don't just add 10 standard deviations together. It's the Pythagorean theorem of statistics. So you have to go, the standard deviation squared plus the standard deviation squared plus the standard deviation squared plus da da da. I need 10 of those variances. So I need 10 standard deviation squared. 10 of these variances, variables, 10 of these variances added up. And then you take the square root. Okay? So that's it. Now, I did not put free response question 4 on this because that's just too many possibilities on the design and the experiment. Okay, just make sure you understand the components and you can do something. Okay, in summary, the test, this final exam is 25 multiple choice only questions. There is no free response. You know, we struggle sometimes with the multiple choice and would prefer free response. But it is 25 multiple choice. The way I did it is I pretty much looked at the review and I said, oh, number one is about probability and, you know, adding the sum up and finding an or problem. So then I go find a multiple choice question that kind of covers that approximate topic. It's not exactly necessarily. Okay, you know, that kind of thing. So that's how I went and designed the exam. And, you know, then number two, oh, that's covering something about the correlation coefficient. So I'm going to go find some kind of multiple choice question about the correlation coefficient. You know, not necessarily anything exactly like this, but something about the correlation coefficient. That way I could make sure I got all the same topics covered, and it was cumulative. All right, so but last thing, this exam will not be, the problems will not count against you. It's 25 questions. They are all 4 points each. So go ahead and answer them all. They won't be marked more off if you answer them and miss them.